All right, we're going to go ahead and get started. So, hello everybody, and welcome to today's webinar presentation. What does being cloud native mean for a database? Brought to you by Couchbase. I would like to introduce you to our presenter, Anil Kumar. As a senior product manager at Couchbase, Anil is responsible for Couchbase server product development, roadmaps, positioning, messaging, and collateral. Prior to joining Couchbase, Anil spent several years working at Microsoft in the entertainment division, and most recently in the Windows and Windows Live division. Anil holds a master's degree in computer science and a bachelor's degree in information technology. And now I'd like to pass it off to Anil for the presentation.
All right, great. Thank you, Drew. Again, hello everyone again. I hope you're all safe and doing well. Thank you for joining me today for the DZone session on what does being cloud native mean for a database. Drew already introduced me. I think that update, that profile is a little late. This past one, so I'm actually again director of product management at Couchbase. So I spent 8 years in Couchbase. I'm responsible for the product strategy, vision, go-to-market for Couchbase Server, our flagship product, Couchbase Server. Couchbase, a cloud-native database, Couchbase on Kubernetes, customers running Couchbase on cloud infrastructure. And here you'll see a list of my Couchbase accomplishments in last 8 years. I'm also a published author of the book Couchbase on Kubernetes. This was published in 2018 when we first launched the first version of Couchbase on Kubernetes. The product is called Couchbase Autonomous Operator. With that, so let me get started. So one of the most innovative and personally fulfilling jobs that I have done in the last few years in Couchbase is that I have successfully led the company's most crucial product strategies to establish Couchbase as a cloud native database. So our vision has been to become a cloud native database. So what does it mean to be a cloud native database, right? So that's the main topic of this session is like, what does it mean to be a cloud native database? So if you do a Google search on the and say define cloud native, you'll get a from the wiki page. You'll get the definition from as a cloud native for cloud native computing. You'll see the definition as the cloud native computing is an approach to software development that utilizes the cloud computing to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds, utilizing the technologies such as containers, microservices, serverless functions, immutable infrastructures, and they are deployed via the declarative code, like the declarative APIs. And these techniques enable loosely coupled systems that are resilient, manageable, and observable, combined with a robust automation. They allow engineers to make high impact changes frequently and predictable with minimal toil. This is exactly what you'll read there. There's a slight variation of this definition when you look it up on the Cloud CNCF, like Cloud Native Computing Foundation. And there's, again, slight variations you'll find when different vendors have their own slight up variation for this cloud native computing. So this is the definition which you'll see, right? But if you look at it from a perspective of like from last few years, what innovations have been done on the cloud native, you'll see prominently these are the 4 pillars of cloud native computing: DevOps, continuous delivery, containers, and microservices. So let's talk about the DevOps first, right? So DevOps came into existence many years ago. So I guess originally from 2008, 2009, when Dev and Ops, there were sessions, like presentations in different conferences when they combined these 2 roles, like Dev and Ops. And in 2011 is when the word was coined, the DevOps. But then it became only popular or with the emergence of containers and Kubernetes in 2015, 2016 timeframe. And before that, this DevOps was there, but it did not get much momentum, or there was not much happening on the DevOps. It's only when the containers and Kubernetes came into existence, this DevOps became very popular. So what does it mean? Right? DevOps is all about the collaboration between a software developer and IT with the goal of constantly delivering high quality software that solves the customer problems or customer challenges. And so now the second part, which is the continuous delivery, another pillar, that is more on the tool chains or the execution mode, right? So the continuous delivery is all about faster time to market. You might have come across this concept. And many of the companies like Netflix have adopted this fail fast, or like they come out with them they come out with ideas and they test out those ideas with their end customer, and they fail fast, right? So, and that's exactly what they have done and been very successful with that. And so to do that, it's all about like bringing the changes much faster to the users, right? Bringing, it's about continuous delivery. And so it's enabled by the agile product development, by, it's about shipping small batches of software to production constantly through automation. The down two pillars, the containers and microservices, these are the key ingredients for the cloud native computing. And these are the enablers of DevOps, and these are the enablers of continuous delivery. And again, the containers itself is a cornerstone of the whole innovations which you have seen in the cloud native computing, right? And so, and then there's the microservices, a modern application development, and see in the past you would see the application developers, and there was many attempts in the past. There was service-oriented architecture, but then the microservice architecture became only possible with the containerization, right? And so now we have this new modern application development. It has become a ubiquitous across the whole enterprise development now. And so it's moving away from that monolithic applications where you have everything built in a single monolithic applications, breaking into a isolated, self-contained microservices applications. So now when you look at these four pillars, and we see that this is again, this matches with the definition which I mentioned earlier. And if you dissect that definition, it will basically match with all these pillars like DevOps and continuous delivery, containers, and microservices. So now that we've seen this, so what does this mean for a database? So what does a database has to do with the cloud native, right? If you ask this same question about what does a cloud native database means to a different database vendors, you might be surprised. They will find different definitions for that, or slightly different way of their interpretation of cloud native database. You'll see the database vendors would say we are cloud native database because we have self-organizing. It's easily scalable, failure resiliency, automatable, platform agnostics, and that is why we are cloud native. And again, from Couchbase, yes, we do also agree that these are all the characteristics of a cloud native. But from our perspective, what is cloud native is what the industry has told us, right? So there is a foundation, cloud native computing foundation, and in the next slide I'll talk about this. All hundreds of projects and hundreds of companies are participating in this in this CNCF foundation. And their definition of cloud native is the technologies, and these are all these open source projects and which are very popular, and they form the cloud native technologies. And so from our perspective, when you know what is the cloud native database is being part of those four pillars. So enabling DevOps, enabling continuous delivery, the database should be containerized and work with the microservices. And this is exactly what Couchbase has done, being part of those four pillars. So we had different challenges in the beginning, right? So as you can assume, so if you had asked me this question back in 2016, 2017, there was a lot of resistance, right? Containers, although became very popular from the development perspective for stateless applications, because there was no state and you could instantaneously create multiple container instances. But then it did not apply we did not apply to the database, because databases are stateful, right? You cannot, you can't like just kill the container and then add a new container, because that will require a lot of rebalancing operation, data movement operation, and depending on the size of your data, it can take it can take hours, it can take days, right? It could be in terabytes or petabytes, and you can't just move from one container to another container, right? And that was those initial challenges. But then both container and the technology and Kubernetes, which came out in 2016 from Google, started becoming more matured. And now nobody has this question about, can we run database on containers? That's an old story. It's matured, and there are many companies who are already in productions and successfully running database on containers. Right? And so one amongst in this database industry, we were one of the first NoSQL database to natively support containers in production from 2016. Right? So the initial challenge we had with the DevOps was there was a impedance mismatch. So stateless applications, you would run them as on the containers, versus the databases were siloed and run on a legacy systems like on bare metal and VMs. That created an impedance mismatch. And so the challenge this was a challenge for us, and the way we solved it is building a native integration with containers and Kubernetes, which removed this impedance mismatch. So now a DevOps can run both the stateless application and stateful application on the same target architecture, right? And so that reduces the DevOps workload, so that they don't have to run the database separately, right? And from the continuous delivery perspective, as I mentioned earlier, the goal is faster time to market, be ability to continuously take changes to different environments to production. And so your database should be in the same pipeline, being part of the same tool chain set, right? And so that required us to be part of those, build those package management software, for example, Helm charts or service brokers. So we need those so that we are part of those tool chains and continuous delivery pipelines. And I mentioned earlier about containers. The containers were the cornerstone of this whole innovation with the cloud native computing, and it basically brings a standardization, and I'll talk about it in the next slide. Lastly, the monolithic architecture was good and similarly in the database we had RDBMS, which is relational database management system, which were scale up architecture, which is vertical, right? And that fit well with the monolithic applications. Now with the microservices, you need a modern database, and that is what the NoSQL and NewSQL databases are, which are distributed and easily scalable technologies. And that's exactly what Couchbase has done here. It's working with the microservices for performance, data governance, data sovereignty. So now let me talk about how does this cloud native come into what does it consist of, right? So when it's a cloud native database, is it just the database and we're calling it as a cloud native, or is it a stack of something, or is it a compilation of something, right? So when you look at so if you go to CNCF and you look at the landscape there, as I mentioned earlier, there are hundreds of projects and hundreds of companies who are supporting this CNCF foundation. And the few amongst these projects, obviously on scheduling and orchestration, you will see Kubernetes, which has been graduated for many years now. And then on the other side, if you look at monitoring, the Prometheus has been graduated, and in logging, FluentD, and then there's Jaeger. And so there are different projects, the open source projects, which are very popular, and they're already graduated. And on the database side, if you closely look at, I have highlighted Couchbase. We are also one of the members of CNCF for many years now. We have participated in KubeCons and KubeCon conferences for many years. So how do we play? What's our play in the CNCF, right? Yes, we do participate, but then does that mean that just because we are participating in the CNCF, we are cloud native? Not really, right? So what does the cloud native means for the database? So now let's take a look at the stack, and this is the technologies which combine them together is when we become a cloud native database. And this is, again, as I said, each vendor has their own perspective, and this is from Couchbase, and this is how we have set our focus, set our vision, set our strategy for becoming a cloud native database. So for a database to run on containers, we need a container orchestration, and we don't have to look anywhere else. Kubernetes is the de facto standard. We picked that. For monitoring, you want to be able to monitor across multiple clusters of your database, and have a single pane of glass to visualize and see your monitoring in one page. And so again, similar to Kubernetes, Prometheus has become a de facto standard, and again, it's again, this was a easy choice for us. So taking the Prometheus as the monitoring solution. Similarly, there is Fluentd, there's Helm, there's Open Tracing, Service Broker APIs, and the list goes on, right? And so what we have done is the one which is relevant to us, right? It's not all of them are relevant, right? So we looked at the projects which are relevant for us to become a cloud native database. We need a container orchestration. What's the best way to integrate or best way to build a integration with the Kubernetes? So we built an operator, and for that we needed an operator framework. So we took the operator framework project, and there's then we have all the other components, like the storage is important for us. So we have GlusterFS, there is Portworx, and then each of those, the Kubernetes platforms itself support different storage classes. We support all of them. For continuous delivery, we need a Helm chart for Couchbase, so we built a Helm chart. Prometheus, we need an exporter for Prometheus. We built that. So what I'm trying to explain here is, like, for us to become a cloud native, it was not just some criteria, which is we should be self-organizing, automatable, platform agnostic, but it is real building all these components together, building a native integrations with the containers, Kubernetes, Prometheus, Helm, Service Broker, CNI, CodeDNS, all of that combined together or compiled together is what is cloud native database for us. So now I'll switch gears and talk more on so far I've been talking about the vision and strategy, but how did we come to this vision? How did we even come with the strategy? It's all starts with what customer wants, right? So we talk to the customer, and as part of my job, when we talk to the customers, what I hear from them, right? So what's driving the adoption of containers and Kubernetes for stateful application? And this is not the list which I had put together just for last 1 year or 2 years. This has been this list has been coming from last many years, right? So it's started from 2016, talking constantly with the customers, and it's their evolving requirements and their needs is what I have compiled this here. So again, when you look at over the period of time, their requirements and their needs changed, and now when you think about like why they need database to be containerized and why would it go mainstream, and I think I should change it to 2021 now. So mainstream in 2020 and 2021, obviously with the pandemic, now it's accelerated. It's because of these reasons. One is they want standardization of development environment. I talked about the impedance mismatch, where the DevOps had to build a stateless application, run the stateless application on the newer architecture, which is the containers and Kubernetes, whereas the database was still left behind on their legacy systems, like on bare metals and VMs infrastructure. And so that was a impedance mismatch, and we wanted to solve that. So now DevOps are able to manage and run and deploy their stateless and stateful application together on the same platform. Right, so it's basically standardizing your development environment. Then there was a challenge from the IT perspective, which was like about the infrastructure, right? Yes, like we have all seen this, and everyone has been focused on the cloud and being cloud ready and cloud focused. So the challenge there was like being able to get the freedom to pick whichever cloud you want to go deploy, and if we have a strategy, and again, this has not become a just a strategy. I think it's a mandatory strategy nowadays to have a multi-cloud and hybrid cloud strategies. So if you want to get that flexibility, be able to be agile and be able to pick any of this cloud or be on the multiple clouds, and then you need again, you wanted to standardize on the cloud infrastructure, right? So you want to pick a architecture which does work on all this, on the different cloud infrastructures, and be portable to any infrastructure, be it a bare metal, VM, private, public, and hybrid clouds. Then there are other stuff, which is standardization of security and standardization of networking and all of that. So it's the main word, if you see across the board, is standardization, right? So they want to standardize, and I think that's the goal they have set. And along with that, they want to be cost effective and be able to get the the cloud benefits, which is the elastic scalability and all of that. So now I'll give you an overview of, again, I talked about the vision, I talked about the strategy of like how we went about and built this backbone for Couchbase and to become a cloud native database with all the stack. But now I'll talk about like how did we actually did that, and how did we actually executed this. And the journey, actually, most of the other database vendors will be from 2016, maybe 2017, and I've seen at least some of them who will start talking about this from 2018, 2019. But for Couchbase, actually, this goes way back, and in fact, I would even say it's beyond 2015. In 2013 is when the co-founder of our company, Dustin Sailing, one of the highest contributor to Memcache, open source Memcache project. He started back then when the Docker itself was in infant state, and 0.4 version of the alpha version of the Docker was released. He was playing with the Docker engine at the time, trying to run Couchbase on containers. But then the actual momentum started only in 2014, 2015, when at least a handful of customers wanted to deploy Couchbase on containers for development and testing purposes in the beginning. And so we launched a beta version of the Couchbase on containers on the Docker Hub. So if you go to hub.docker.com, you'll see Couchbase repo, and we are one of the top 10 repositories in the Docker Hub. We have more than 20 million downloads since we've been there from like 2015. So when we launched beta, we saw a increasing demand from customers. Initially, they wanted to run it only for development and testing. Then they wanted to run a small use cases, they're not mission critical, but small use cases in production. And so that gave us again, as I mentioned, my job being in the product management is to see where the market is going towards, and then also what customer wants. And so with that, and also we looked at other database vendors we're shying away from supporting containers. We wanted to take a leadership position in that. So we became a thought leaders in the industry by announcing we were the first NoSQL database to announce production certification of Couchbase on containers. What that means is that we built an entire framework for running Couchbase tests on the containers. So we had a test framework which runs Couchbase on the VMs and bare metal, but then we had another test framework which was completely containerized, and we would run all our tests on the containers. And so that was back in 2016. And when we released Couchbase Server 4.5, we announced Docker production certification of Couchbase on Docker. And then, obviously, there are customers who went to production with that. They had challenges. They had to write scripts to deploy and manage Couchbase on the containers. It was not trivial. There was a lot of work, and so obviously we saw the need for container orchestration, and so we started investigating container orchestration, different container orchestration back then. And by 2017, it became obvious Kubernetes had has become a winner. So we picked Kubernetes as a container orchestration to build our integration. So this was a stepping stone, in my opinion. This was a stepping stone. One of our customer, Amadeus, became a partner with us, and then we partnered with Red Hat, who had changed the older OpenShift version to newer OpenShift, which was completely Kubernetes based. It's enterprise Kubernetes. And so we partnered with our customer Amadeus and Red Hat and built a proof of concept, which was then showcased in the Red Hat Summit in Boston in 2017. And so from there, we launched the Couchbase Autonomous Operator 1.0 in 2018. And we had multiple minor releases. And then 2.0 was launched last year. And then in December, we had another minor release of the Couchbase Autonomous Operator, right? And so you see there is a history, and we have not just been talking about these containers in Kubernetes from the last couple of years. It goes all the way back to 2013 and 2015. Right, and so I'll speed up a little bit faster so that I do want to have a quick demo. So I don't want to leave the presentation just with all these slides. So I'll just quickly cover a few things here and then jump to the demo. So Autonomous Operator, put simply, it's basically a integration between it's another product. It's a new product itself. And so the job of this Autonomous Operator is to programmatically automate all the operations of Couchbase on Kubernetes. And so it's basically, the way you look at it is, it's taking the best of Couchbase, best of Kubernetes, and it's codifying it, or it's the infrastructure as a code, you can say, or it's basically from the definition of the cloud native computing. It's user gets a declarative, they can declare, and then the Autonomous Operator goes and programmatically automates all of that. And so the experts of Couchbase who built the Couchbase server, they are the one who are automating all those operations, right? So we know from many years of experience running Couchbase in production for various customers, we know what are the do's and don'ts, edge cases, and so we basically took all of that knowledge and then built this operator, which is it's a best practices automated in some sense. Here's a very high-level architecture, right? So there's there's Kubernetes cluster, and it has its master. And there are different components of the master etcd, and the one metadata, the key value metadata store. So for Couchbase Autonomous Operator, there are two important components. One is the admission controller, and then the other one is the Autonomous Operator. What's the role of the admission controller? It validates every single request we make to the Kubernetes. It also does another important job, which is like if you don't specify something, it will default the values to you, right? So, and I'll show you an example. We have this YAML file, and if you don't specify something in the YAML file, that all will be automatically defaulted by the admission controller, right? So, and as I said, it protects the user from making any misconfigurations, and it gives a user-friendly error messages so that you know what went wrong. The Autonomous Operator has, again, two subcomponents, controller and resources. Everything under the Kubernetes is managed through these resources, right? So for Couchbase, when you deploy the Couchbase cluster, the pods, the services, the persistent storage, everything is a resource. And in the example I'm going to showcase, I will take one example of when you deploy using the resources for buckets and the users and stuff. So I'll show you an example. So Couchbase cluster itself is deployed and using the operator, and obviously we are a database, and so you'll see that there's computers are running on the pods, and the data itself is getting stored on the persistent storage. We mentioned earlier about the integration with Prometheus. We have a official exporter for Couchbase, which gets published to the Prometheus. We have templates for Grafana dashboard and also template for the alert manager. One innovation of our own, the database itself, like I explained to you about monolithic architecture to microservice architecture in the application. In database also, not only just we moved away from the scale-up architecture, but also with the scale-out architecture, we have gone further innovated and break them into separate services. So typically, when you think about database, we all think about storing the data and retrieving the data, but a lot more goes behind the scenes. So there is not just the CRUD operation, there is also you run queries, and to make the queries performant, you have indexes, and there could be a search indexes or there could be analytics indexes, right? So there are different different services which are running, and so usually if you see most of the database would run all of the services together, that creates a contention, that creates a problem, because when, let's say, if you have a long running query which is hogging the machine, it will impact your CRUD operation. So what we have done here in Couchbase is I brought a microservice architecture in the Couchbase itself. We break these services into separate services, isolate them from each other, so that when and they also have this flexibility to scale differently. So data service needs to scale horizontally, but your query service needs to scale up because you need more CPU, or for your indexes you need to have more memory, for example. So for each of those, you need a heterogeneous scaling, scale out, scale in, scale up, and scale out architecture, and that's exactly what we have done here. Right. So I will quickly cover a few things on the product capabilities, and just to showcase that what we have done. And it's again, this is all about the execution. This is all about how we build this backbone for Couchbase as a cloud native database. Initially, it was all about the Couchbase integration with Kubernetes, and then the capabilities we are building with Autonomous Operator, and then we started building the integration with Prometheus, Service Broker, Helm charts, all this storage classes and CNI plugins and stuff. So that's came later, but initially it was all about automated provisioning. So automate the whole deployment for database, and the auto recovery when the pod which is running for pod running the Couchbase dies, the operator should be able to self-heal and self-recover. And so on-demand scaling, and this was back in 1.0, by the way. So the on-demand scaling, the user has to go and change the YAML file to scale up and scale down. But in the last release, in 2.1, we also came out with auto scaling feature, and I'll talk about it. Finally, the configuration management. So being able to handle all the configuration for Couchbase, the cluster configuration, bucket configuration, your replication, all of that with a single configuration file. And so we production certified running Couchbase on Kubernetes, open source Kubernetes, and also Red Hat OpenShift and the 1.0. 1.x, so there were two minor releases. One focused on the supportability, like we shipped tools to make this product supportable. Like if the issues have happened, we have a tool which grabs information from Kubernetes as well as from Couchbase Cluster and gives us a detailed information about what went wrong. So that's like the tool which is already shipped in the product. In 1.2 version of the product, we had one of the pain points for our customers was the upgrade process. We are a distributed database, and as you can imagine, depending on the size of the data and depending on the size of the cluster itself, like it could be having 10 nodes or 20 or 60 or 100 nodes. If you want to upgrade your cluster entirely, it sometimes can, depending on the size of the data and stuff, it can take hours, days, weeks, in some cases months, because you want to make sure that you prioritize your application, right? You don't want to have a downtime. So you start your upgrade process. You might choose to pause it for some time, then restart it. So there are various reasons. The upgrade process was complex, and customers would spend significant amount of time testing it in their test environment. And so we wanted to take obviously this was one of the goal for us to make this easier for the customers. So goal was to automate the upgrade itself. So now with the operator, we have taken care of all those edge cases and stuff and automated the whole upgrade process. One of the requirements for customers was being able to connect to the database wherever it is deployed. It could be deployed on the cloud, but I'm building my application on my Mac machine. I should be able to connect to my database, which is deployed in AWS or Azure or Google. And so we needed a public connectivity feature, right? So that was again shipped in the 1.2. And I mentioned about the Helm chart. This was another another cloud native technology integration. And then from the platform itself, many customers were coming with requests to production certify Couchbase Autonomous Operator for different cloud managed Kubernetes services like EKS, AKS, and GKE. And so we decided to production certify all those platforms. All right. So 2.0 was a big milestone for us. This was another major release which was launched last year. If I talk about the biggest thing which we have done is when you look at the architecture, I talked about the resource types. So before we had a single resource type, which was Couchbase server, the Couchbase cluster, and so you would put pretty much all your configuration and topology information, port specification, persistent storage specification, all of that in one configuration. Now with the 2.0, we further break that down into multiple resource types. So we have granular control as well as granular security for those resource types. So if I want to, I want to have a bucket administrator. So I know the database administrator who has only access to create databases and manage the databases. So the resource type he will be utilizing is Couchbase buckets. So likewise, if I'm a security administrator and I just want to manage the RBAC users, the role-based access control users, create users, manage them. And so I have a resource type, which is Couchbase user. So likewise, we have a resource type for replication, for backup and so on, right? And so that was one big innovation there. Along with that, since we have now the resource type and granular control over those resource type, we went and now automated all the other stuff, which is creating the users, creating the buckets, backups, creating the replication streams between the source and target clusters. So all of that was possible with this new architecture, with the operator architecture. So there's the certificate authentication using the mutual TLS support, and similarly we continued production certifying all the platforms, including open source Kubernetes and Red Hat, EKS, AKS, and GKE. So 2.1 was, as I mentioned, December 2020, just before the December month. So this was a minor release, but then it did have a bunch of important features, like auto scaling was a big one. Usage metering, many customers wanted to have a granular report of like how much usage has been done by their application team. And so the usage metering provides you that granular report. So support for STO envoy is obviously coming from the customers who are running microservices, and they want to have standardization of the way they interact with the different services. And then service broker is all of this which you see here is all coming from the customer requests, right? So we listen to the customer, their needs, and prioritize them, and this is how we have been building a roadmap. So service broker was again customer request, and it's basically hides the complexity of like all these steps you have to take. Even though we have simplified deploying the Couchbase cluster, you still have to take multiple steps to deploy the Couchbase operator, deploy the CRD, do the role banding and all of that. And the service broker further abstracts all of that steps. It makes it super easy in terms of like what the user will see is they'll see plans on the service catalog, and when you execute this plan, it will go and create the operator. It will create the whatever necessary role banding, security stuff is required. It takes care of all of that, then deploys the Couchbase cluster, right? So just imagine, and the analogy for this is like if you go to any of these cloud providers, and when you look at those services, when you click on this, they give you this interface, and you just have to input some values, hit submit, and it takes care of, it abstracts and takes care of all the deployment for you. Likewise, the service broker does it for Couchbase cluster. Cluster hibernation is it's another very important cost-effective feature, which is for development purposes at this point. So the idea here is, if I'm using the Couchbase cluster for my development and testing, over the weekend, I don't want to keep my cluster running, so this is going to cost me if I'm running it on cloud. So I can essentially pause the cluster, and then when I come back on Monday, I can resume the cluster. So what happens is your data is still intact. All your test data or your development data is still intact on the persistent storage, which is cheap, versus your compute is all killed, right? So your all compute resources have been having garbage collected, and once you come back on Monday, restart the cluster, it will recreate the cluster, but then reattach to the same persistent storage, reconsider the data. I think enough of this, and so I'll just jump now to the demo so that I have another 15 minutes to quickly show the demo. So jump here. All right. So for the demo, what I have done is I have created two clusters. One cluster in the EKS, the Elastic Kubernetes Service on the Amazon AWS, and then also, sorry, one second. And I have created one another cluster on the GKE. So this is the Google Cloud GKE, Google Kubernetes Engine, right? So I want to showcase, and there are many things to demo. Obviously, as I mentioned, like all these feature capabilities I have been talking about, auto scaling and the cross data center application, all of that. For the demo, what I'm going to do today is just to showcase how easy is it to deploy Couchbase, the Couchbase cluster on the EKS, and the exact same configuration, exact same topology can deploy with the same commands on the GKE, right? So you'll have a exact replica of your cluster on the EKS and GKE. And then from there, you can do many things. You can obviously do if you want to lift and shift from one cloud to another cloud, or you want to have a multi-cloud architecture, all of that is possible, right? All right, let me get started. So go to my terminal, and let me first connect to my EKS cluster. All right, so I want to quickly show you I have already deployed the Couchbase operator. So this was only two commands to run to create an operator. So there is a tool we have created in Couchbase called the operator called CB-op-CFG. I literally ran this two commands to deploy the admission controller and operator. It will come back and say this is already created because I have already run this command before. But yeah, so this already exists. So what I'm going to now show you that is both of my admission controller and operator are running. So kubectl get deployments, and you'll see that both of them are running. So in my next command, what I'm going to do is run the single command to create the Couchbase cluster, create the Couchbase user, and in this case, I'll create a single user, and I'll give that user access to my bucket, single bucket. So if for the demo, I've created this one single command. So let me go back and show you what this command is. Again, it's a kubectl command, and just doing it on the default namespace. And so first create, it's going to create the secret, and this is the CB example admin. So this is the for my administrator, I'm creating the username as administrator and the password as password, and keeping it simple. And so the next thing I'm going to create is the bucket resource, which I was mentioning about, the Couchbase bucket resource. I'm giving the quota of 120 MB for that. And then there is the Couchbase cluster itself, right? So if you see this is my Couchbase cluster. The name of the cluster is CB example. These are all my cluster settings, like cluster name, data service quota, index service quota, the auto failure timeouts, and all of these are my cluster settings, compaction settings and stuff. And then I'm also enabling backup on this cluster. So I'm doing this all through the single configuration file. So, and also the networking, I'm exposing the admin console so that I can log into my Couchbase web console and look at the cluster. And also with this, for the deployment, I'm creating 3 pods, and these 3 instances will run all the services of Couchbase. And as I mentioned earlier, we can pick and choose and say for the first 3 nodes, I want to run data. For the next 2 pods, I want to run index and query and different services. For the demo purpose, I'm just running it all in all the services. Finally, I'm also creating another user, like secret for a CB example user, and again, password for this user, and this is where I'm going to create the user for this bucket and give them the access to the bucket. Okay. All right. If I hit enter, so it will now start creating. So you saw it created the secret, created the bucket, created the cluster, and then it started deploying, created the user, right? So it will usually take a minute and a half to get the whole cluster up and running. So if I run the kubectl get pods, so it hasn't created anything yet. So let's see the example. Give me 1 second. Okay, so it's coming up. While this is happening, what I'm going to do is jump to my the GKE cluster and run the same commands there. So for that, I need to get the kubeconfig. So give me 1 second. Run this command. Okay, all right. And I'm going to run the exact same command which I run there, right? So as I said, I want to have an exact replica of the cluster which is running on the EKS. So just want to make sure that my admission controller and operator both are running. So if I hit the kubectl get deployment, it should come back and say, yes, they both are running fine. And I'll copy the same command which I just ran on the EKS and hit enter. So now it's doing the same thing on my GKE cluster, right? So it's basically it's going to create the pods. All right, so well, now this is happening on the GKE. I can now go back to my EKS cluster and see if my cluster is up and running. So it looks like my cluster is up and running. Let me get the context back. And let me take a look at the pods first. Okay, all my three pods which I had deployed, all of them are running. And now I'll get access to my web console. I'll do it here. And so now that I have done this, I'll switch to my cluster. So if I do refresh, all right, coming up. So the goal I'm trying to show here in this demo is it's very, very easy, and I pretty much I don't even have to again, if I'm using Helm charts, even it would be further simplified, and it would even deploy with the whole admission controller and Couchbase cluster with a single command. Sorry, my bad. It's coming up. Oh, let's see. In the meantime, I can also all right, let me check. Okay. All right, let's see my cluster. So these are the 3 pods which I have deployed. And as I showed you in the topology, all the services are running. If I switch to buckets, this is the database. So we have one default bucket created. If I go to security, I have created one user and I have given this user access to the default bucket. So application access to the default bucket, right? So this is the EKS cluster, right? Now I will switch back to my GKE and see if my GKE cluster is up and running. So give me 1 second. I would have to get this context back. And then I will have to run to check if my cluster is up and running. Okay, all right. So if I now switch to my the browser and refresh it, it should show me the GKE cluster. Yeah, So this is my GKE cluster. So the point here I'm trying to make is like without making any changes to the configuration, literally I took the same YAML, I had used it for EKS and I'm using it for GKE. I could do that same thing for Red Hat OpenShift or AKS or any of the Kubernetes platforms. It would work magically the same way, right? And as I said earlier, the goal of my demo is to showcase how easy is it. There are a lot of things to showcase. I can show, if I want to scale up, I can do that with a single command. If I want to upgrade the cluster, I can do that with a simple command. And again, auto scaling is a new feature we introduced. We have integration with Prometheus. I can enable the Prometheus on the cluster, and I can visualize them. So, but again, these are all the demos. We can see them in the and again, if we go to our Couchbase documentation, we have the tutorials and stuff which we have written. Plus, if you go to couchbase.com and resources, you'll see a bunch of webinar sessions and stuff where we have demos of those. So, but my goal here was to do the demo, simple demo to showcase like how easy is it to run deploy the Couchbase cluster on the any Kubernetes platform, and it's fully automated, self-healing, fully automated upgrading stuff. Right? Let me switch back, and I have a couple of slides to cover on the on the key benefits, and I'll end the session. So give me 1 second. So the key benefits, I won't take much time. So basically, if we look at, there are three main reasons, like better, faster, and cheaper, empowering developers. And I talked about standardizing for the development environment. It's like we unlock the team productivity with self-service access to database, standardization for development, test, pre-production, production, and run and manage. And there's no impedance mismatch, run and manage Couchbase database on the same target architecture as your stateless applications. Unlock business agility, which it gives you full flexibility to run across any infrastructure on any cloud, multi-cloud, hybrid cloud. And finally, it streamlines the operations with all the automations we have done, like starting from provisioning, from upgrade, security, replication, all of that. It reduces your DevOps workload. It it reduces your operational complexity by 90 to 95%. Right? So it's better, faster, and cheaper is what are the key benefits. And again, then the microservices, it becomes much easier now to run your database closer to your microservices as a data service for performance reasons, data governance reasons, data sovereignty reasons. And then lastly, the business agility I mentioned already, which now we can have ability to do multi-cloud or hybrid cloud strategy. With that, I'm going to actually end my session. And there are some good feedback from the customers. Like AT&T has been one of the champions of Couchbase, and then they have been giving us a great feedback. Likewise, we have other customers like BD Health and CenterEdge, Staples, and other customers who have given a great feedback to Couchbase and Couchbase Autonomous Operator. All right. If there's any questions I can take from here, I can let me take a look. All right. There's one question which someone is asking. So it's what are the other advantages of running Couchbase, a NoSQL database on Kubernetes? I talked about various things about like flexibility, about the user like impedance mismatch and all of that. But there is also another reason, which is performance. When you look at the architecture of Couchbase running on the Kubernetes, you saw this is one important. If you have noticed that we are running the Couchbase instances on a compute like pods, whereas your data is stored on the persistent storage. This is a huge benefit when you think about separating the compute and storage. Now, if I lose my compute, if I lose my host machine where my Couchbase instance is running, my data is still intact. So I can when the operator creates the new pod or new instance for Couchbase, it will reattach to the same persistent storage. And so the time to recovery or time to self-heal and get back to the cluster has reduced significantly, because the data is still intact, and we have to just do the delta sync and then come back to the cluster, right? So that's another huge advantage from the performance perspective. And there are other things, obviously, as I mentioned earlier, if I want to lift and shift from one cloud to another cloud, or move from and have a multi-cloud architecture, that's all possible with the running Couchbase on Kubernetes. Looks like there's another question on the service broker. Yes, as I mentioned, this came out with the 2.1 release in the December. Feel free to go ahead and give it a try. This is in the developer preview right now. So we have two plans: a basic standard plan, and then there is an advanced standard plan, which gives you ability to run with a single command. You can create a Couchbase cluster, deploy the Couchbase operator, Couchbase cluster. You can change the plan. You can change the plan to increase the number of pods and stuff. But as I said, it abstracts away all the complexities and makes it easier to deploy the Couchbase cluster.
Well, with that, I would like to thank you, Anil, for a phenomenal presentation. Secondly, DZone would also like to thank Couchbase for providing the audience with a great webinar. Lastly, DZone would like to thank everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day.
Thank you. Thank you so much. Bye-bye.